This is 2-5, the compound interest formula. And our quote is, to make a million, start with 900,000, okay? So this basically shows how we can take and start with a certain principle and increase it. And our objectives will be to understand the derivation of the compound interest formula and to make computations using the compound interest formula. Now we have only two terms that we need to define. And first of all, it's the compound interest formula. This relates principal, interest rate, number of times interest is compounded per year, and the number of years the money will be on deposit to find the ending balance. And then the other term is annual percentage yield, or APY, and this is the simple interest rate that would be required to give the same dollar amount of interest that compounding gave. All right, so let's look at an example. Jose opens a savings account with principal P dollars that pays 2% interest compounded quarterly. What will his ending balance be after 1 year? Well, first of all, his balance is going to equal whatever he started with plus whatever interest he's going to have earned, okay? And we talked about 2% interest and compounded quarterly. That's 4 times a year, okay? So let's start off with the basic simple interest formula, I equals PRT, all right? And if we solve that, we come out with 0.02 over 4 times P, all right? So his balance after the first quarter is simply going to be his principal plus the interest. Well, we calculated the interest to be 0.02 over 4 times P. So his balance after 1 quarter is going to be P times 1 plus 0.02 over 4. All right, his balance after the second quarter is simply going to be the balance after the first quarter balance after the first quarter plus the balance after the first quarter times 0.02 over 4. And if we factor out the balance after the first quarter, we know what that is equal to. That's equal to this up here, all right? So that's the balance after the first quarter. So I'm going to substitute that in for B1 down here, okay? And if we simplify, his balance after the second quarter is P times 1 plus 0.02 over 4 squared. All right, so let's look at the balance after the third quarter. And we substitute in the balance after the second quarter. And if we simplify, we end up with the balance after the third quarter is equal to his initial principal times 1 plus 0.02 over 4 raised to the third power. Now notice some things about the balance after the first quarter, the balance after the second quarter, and then the balance after the third quarter. And you'll notice some similarities and some patterns here. And if you look at those patterns, you'll find that the balance after the fourth quarter is simply equal to this. All right? Quarterly, that's where this 4 comes in. And it's 4 times again, so that's this. This is your interest, all right? And here's your principal, all right? So this is his balance after 4 quarters. So let's look at another example. If you deposit P dollars for 1 year at 2.3% compounded daily, express the ending balance algebraically. Well, let's see what it'll look like. All right, now, we're compounding daily, all right? This is our interest, 2.3%, and we start off with a principal of P dollars. So after 365 days, what's our balance going to look like? It's going to look like P, parentheses, 1 plus, here's your interest rate, 0.023, and that's over 365 since it's compounded daily, and the exponent is 365. So this is what the ending balance is going to look like. And it's basically based on the previous formula and how we can come up with, a pattern here. Here's another example. Nancy deposits $1,200 into an account that pays 1.7% interest compounded monthly. What is her ending balance after 1 year? Round to the nearest cent. Again, using the pattern that we've talked about, here we're compounding monthly. So 12 months in a year, so there's 12 there. The exponent is also 12. Our interest is 0.017, and our principal that we started off with was $1,200. Now, in order to do this on your calculators, this is what I suggest you do, all right? You start with this right here, okay? So take 0.017 divided by 12 equals plus 1. Then you raise it to the power 12. Then whatever you get for an answer, you multiply it by 1,200, okay? So if you're using your calculators, start with the 0.017 divided by 12, get what that's equal to, add it to 1, get what that's equal to, raise it to the 12th power. When you're raising to the 12th power, remember the key you use on your calculator is that caret key or the inverted V. Once you get what that is equal to, where it raised to the 12th power, then you multiply it by 1,200, and this is what you should get for your answer. All right, so Nancy, from our previous example, receives 2 other offers in the mail from other banks. One is an account that pays 1.3% interest compounded daily. The other pays 1.9% compounded quarterly. Would either of these accounts provide Nancy with a better return than her current account? If so, which account? All right, so let's look at the first offer, 1.38%, I'm sorry. And that's compounded daily. So don't forget now that this is going to be 365 here. So we got 365 here, we got 365 here. There's the interest rate. And we calculate it out. Again, remember, on your calculators, do this fraction in the middle, add 1 to it, raise it to the 365, multiply it by 1,200, and we come out with a balance of 1216.67. Now, the other amount is 1.9%, but this is quarterly, not daily. So this is 4 times a year. Not as frequent, but the interest rate's a little higher. So obviously we got our 4 for quarterly, our 4 here. To calculate this on your calculator, again, 0.019 divided by 4, whatever that's equal to, add 1 to it, whatever that's equal to it, raise it to the 4th power, whatever that's equal to it, multiply it times 1,200. And we come out with a value of 1222.96. And this is actually better than her previous offer. It's better than this first offer. So even though this was compounded only quarterly, the interest rate was high enough that this was the better return for Nancy. All right, so what is the compound interest formula? This is the compound interest formula right here, all right? Now, there's some slight differences. First of all, B is your ending balance. P is your principal or original balance. R is your interest rate expressed as a decimal. N is the number of times the interest is compounded annually. How many times for each year? Now, this formula allows you to calculate your balance for multiple years. Notice we've got a T up here. We've got NT. All right? If it's just 1 year, T is 1. But you could figure this out for like 3 years, 4 years, 5 years. So that's why we've added T up here. All right, here's an example. Marie deposits $1,650 for 3 years at 1% compounded daily. What is her ending balance? All right, so we're going to use the formula. Here's her principal, $1,650. All right. Daily, remember that's up here, daily. So therefore, this is $365, and this is $365. But notice, this is for 3 years. So we have to put the t in, which is 3 years. All right. How do we do this on a calculator? Again, fraction first. 0.01 divided by 365. Whatever that is equal to, add 1 to it. Whatever that's equal to, raise it to this power. Now you're going to use parentheses in the power because you want 365 times 3. Whatever you get for that answer, multiply it by 1650, and our balance comes out to be, after 3 years, $1,700.25. Now we got Kate. Kate deposits $23.50 in an account that earns interest at a rate of 1.1%, compounded monthly. What is her ending balance after 5 years? Round to the nearest cent. All right, here's her formula. Here's the formula she's going to use. Remember, it's compounded monthly, so that's where we get the 12 here. But we want after 5 years, so that's where this 5 comes in, all right? And our interest rate is 1.1%. Initial principal is that. Again, figure out the fraction first. Whatever that's equal to, add 1 to it. Whatever that's equal to, raise it to 12 times 5, that power. 12 times 5 is easy enough, that's 60. What you get for an answer here, multiply it by 2350, and you come out with her balance is, after 5 years, is $2,482.81. All right, now let's talk about APY. Sharon deposits $8,000 in a 1-year CD at 2% interest compounded daily. What is Sharon's annual percentage yield to the nearest hundredth of a percent? Okay? All right, so first thing we're going to do is figure out how much interest she's earned, dollar amount of interest. So it's compounded daily, so there's a 365. It's for 1 year, so then we only got the 365 up here. Interest rate, 2%, so that's it, this right here. So we calculate this out, fraction plus 1 raised to the 365 times 8,000, and we come out with $8,161.61. Now, she started off with a balance of 8,000, so obviously the interest she's earned is $161.61. Now, if we use our simple interest formula, remember APY relates to simple interest. We've got I equals PRT. Well, we're trying to solve for annual percentage yield, or R. So R is simply equal to I divided by PT. I, we already figured that out. That's this 161.61. Our interest, our principal is $8,000. I'll get it right. And we're only doing this for 1 year. So if we calculate it out, we come out with 0.0202, or the equivalent simple interest, or APY, is 2.02%. Now, we could also use a formula, an APY formula, rather than doing the calculation we did on the previous page. All right, and this APY formula is this, okay? Annual percentage yield is 1 plus interest rate over the number of times compounded per year, n, minus 1. So if I plug in 0.02, 365, we come out with the same answer, okay? So if you want, you could also use this formula to calculate APY.